And welcome back. This is going to be a practice problem video that, practice problem video for lessons, that is not how you spell lessons, lessons 2 and 3. So this is going to be focusing on saturated, mostly it's going to be focusing on reading thermodynamic tables, but knowing what saturated versus superheated gases, which we go over in lesson 2, will be important. So for this problem, I am going to ask, what is the specific volume, internal energy, and quality of nitrogen at 260 degrees Kelvin, or just Kelvin, and 200 kilopascals. Now I'm going to put a little link to the tables that we're going to be using for nitrogen here. And if you want to try this problem, pause it now and do it on your own. And I will do this problem now. So we're asked to find specific volume, internal energy, and quality. Now, specific volume and internal energy are both values we get out of the table, and then we would have to do the reverse of the process that we show in lesson 2 to solve for x, to solve for quality instead of the other way around. Now, one huge hint. Now, first we have to identify whether or not it's a saturated versus superheated. So the biggest hint is that we're given both a temperature and a pressure. Now, you need at least 2 thermodynamic properties in order to find all the rest of the thermodynamic properties. However, unless we know the quality of a saturated substance, we can't figure out anything. So, since we're given both temperature and pressure, if it was saturated, it wouldn't help us at all. So we can assume. So I would start this search trying to find these two values matching up in a superheated table. So if you do look up these values in a saturated table, you won't find a matching pair. In fact, nitrogen can never be 260 degrees Kelvin and be saturated. It just doesn't match up that way. So instead, it's a superheated vapor. And because of that, we know X is undefined. So we figure out what X is. Now, internal energy. Alright, so let's open up the table. I can't show it to you on my end, but if you open up the superheated table for ammonia, we're going to be looking at the 200 kilopascal table, or in this case the 0.2 megapascal table for ammonia, and look up the 260 Kelvin entry. And if we do that, the specific volume is labeled very nicely at 0.77118 meters cubed per kilogram. And internal energy is 192.392 kilojoules per kilogram. Alright, very simple. Just looking up values. In a little bit we're going to get a little more complicated with linear interpolation. There'll be a practice video along with that as well. And like always, good luck with thermodynamics.